Ignition sequence start.
Good morning, and welcome to this peek inside the International Space Station Flight Control Room at Mission Control Houston. The Orbit 2 team is having its turn on console, keeping watch over station systems and assisting the Expedition 66 crew members as they wrap up another work week in space. Commander Anton Shkaplerov and his crewmates focused this week on science operations and keeping their station operating smoothly and safely. But they did that with an eye toward upcoming operations with multiple cargo vehicles that are just over the horizon.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, the crew on the International Space Station remained focused on science while awaiting new arrivals. Roscosmos will be launching the uncrewed Progress 80 mission to the orbiting outpost. The Progress MS-19 cargo spacecraft is set to launch on Monday, February 14th from the Baikonur Cosmodrome in Kazakhstan. The Progress spacecraft will then spend the next few days in orbit, catching up to the space station where it will dock on Thursday, February 17th at 2 a.m. Eastern. Progress MS-19 will automatically dock to the zenith port of the Poisk module. It is currently planned to stay docked for 196 days, supporting both Expedition 66 and Expedition 67 missions aboard the ISS. This week on board the orbiting laboratory, Matthias Maurer teamed up with his crewmate Mark Van de Heij to work on the European Space Agency's experiment to develop acoustic tweezers. The duo conducted several experiment scenarios for the ultrasonic tweezer experiment to evaluate the possibility of trapping various objects, either single objects or multiple objects, in the acoustic field. The objective of the ultrasonic tweezer project is to develop acoustic tweezers that use sound to allow for remote and contactless manipulation of materials in a microgravity environment. In the experiment, an ultrasound beam is shaped so that it produces a trap from which an object cannot easily exit. By moving the beam, the object can be moved to a new position with very good precision. It will not be long before we see new faces join our crew on the space station, with 2 missions in final stages of preparation. NASA and its international partners approved the crew members for Axiom Space's first private astronaut mission to the International Space Station. The flight, called Axiom Mission 1, is targeted to launch Wednesday, March 30th from Launch Complex 39A at NASA's Kennedy Space Center in Florida. The crew of 4 will fly on SpaceX Crew Dragon Endeavour to the space station. After 10 days in orbit, the Axiom 1 crew will splash down off the coast of Florida. NASA and SpaceX has also confirmed that they are still targeting launch of the Crew 4 mission to the ISS for Friday, April 15th. NASA astronauts Kjell Lindgren, Robert Hines, and Jessica Watkins, as well as ESA astronaut Samantha Cristoforetti, will launch on board a new Crew Dragon capsule and dock with the space station for their 180-day mission. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
The Expedition 66 crew members should see a Russian cargo vehicle arrive in less than 1 week, followed a few days later by the next Northrop Grumman Cygnus cargo ship, targeted to launch late next week, carrying food and other crew supplies along with new experiments. Here's a preview of some of the new science headed to orbit later this month. Astronauts on the International Space Station are the lab assistants for scientists conducting research in orbit, and they also become repair technicians when experiment hardware needs some work. Last year, astronaut Megan MacArthur wore a mixed reality headset, a Hololens, to test its usefulness while repairing the Cold Atom Lab. And that provided the team at the Jet Propulsion Laboratory with a live astronaut's eye view of the scene and let them insert virtual graphics into the field of view for MacArthur to see.
We are just now joining the meeting that you initiated, and we see your video. It looks good. We feel that the HoloLens will be very useful for real-time guidance as we work to free harness cables so that you can pull out the existing Splice 7 and replace it with the new Splice 7B.
So now we're disconnecting.
We can talk you through most of the steps so you don't need to keep referring to the procedure.
J16 and J17, these little fasteners on either side are non-captive, is that correct?
This activity is called remove and replace, and it involves replacing an existing piece of hardware. It's very important that every step is followed very carefully, and she gets the go-ahead from the team before she proceeds.
Timing-wise, do you want me to try to troubleshoot the HoloLens or continue to disconnect the connectors?
Disconnect.
Okay, so good news, the 564 does fine. I've removed the P16 connector. Then I tried to recover the call. I closed everything I could find to close. Tried to reopen and telling me now no internet connection in an area. So timing-wise, do you want me to
I think this is going to be really fruitful for the future. This will open up a new branch of physics research in space.
We have a good instrument install and a good demonstration of the HoloLens virtual reality glasses with the remote assist. So thank you again. We're looking forward to powering this up and demonstrating a successful R&R. We'll talk to you soon. Thank you. Bye.
Expedition crew members from 5 different countries supported science operations on the International Space Station in dozens of experiments last year, taking advantage of the absence of gravity to learn things that just couldn't be learned here. Now take a look at the best science photos from the station from 2021. International Space Station crew members provide the hands for hands-on science research, but they spend some of their time sharing the experience of being in space, and they talk to students about key scientific concepts. In this news demonstrations video, astronauts Shane Kimbrough and Aki Hoshide demonstrate the centripetal force that keeps the space station in Earth orbit.
Hello, my name is Shane Kimbrough, and I'm an astronaut living and working aboard the International Space Station. We're currently orbiting 250 miles above the Earth's surface at approximately 17,500 miles per hour. You may be wondering how it's possible for the space station to be continuously orbiting Earth. Well, today we're going to answer that question and explore centripetal force in the microgravity environment of the space station. Let's get started. Before we dive into centripetal force, it's important to look at Newton's first law of motion, which states that an object will continue moving with a constant velocity along a straight path unless acted upon by a net external force. This means that the space station will move along a straight path if it weren't for one key external force acting on it, Earth's gravitational pull. Another name for this external force is centripetal force. A centripetal force is any net force that keeps an object moving along a circular path. Gravity, in this case, is a centripetal force because it is the force that is keeping our space station moving in its circular path around Earth. All right, here's our example. We have Aki here that has an object tied to a string. It's just a yo-yo, but it's an object on the end of a string. He's going to whirl this object around, attached to the string, so that it's moving in a circular path. The string in this demonstration provides a force of tension, which is the centripetal force keeping the yo-yo revolving around Aki's hand. It's important to note that centripetal means center-seeking. Therefore, a centripetal force is a center-seeking force. Centripetal force is always directed inward, toward the center or axis of revolution. This is because it's the force of tension from the string, pulling inward, that keeps the yo-yo revolving around the axis of revolution. Now Aki's going to set the object moving in the circular path free and remove that centripetal force by releasing the string. As you saw, once the tension from the string or centripetal force was removed, the object continues to follow Newton's first law of motion. It keeps moving at a constant velocity along a straight path relative to the space station. Can you think of other examples of centripetal forces back on Earth? To learn more about centripetal force, use the corresponding classroom connection to conduct your own experiment and discover other ways centripetal forces play out in your everyday life. Thanks for exploring some physics with me today. See you again soon.
By virtue of being 250 miles above the Earth and orbiting over different parts of the planet every day, the International Space Station provides a handy spot from which to gather data for a number of experiments that are designed to learn about the home planet of their creators. Here's a look at a number of those experiments, including the ones that involve astronauts with cameras in their hands.
Earth's climate is the product of many rich and complex systems. It's affected by water in its many forms, on land, in the air, in the oceans, and as ice. It feels influences from vegetation, from soil conditions, from the carbon cycle, from human impacts. We study and observe our planet's ever-changing conditions in many ways, from many locations. One location in particular provides a unique and powerful vantage point, allowing us to see our planet in high detail and on a broad scale: space. The International Space Station is home to many instruments that help with the study of our planet in a variety of ways. Each is an amazing resource for scientists and researchers, but together, they paint a picture of Earth richer and more detailed than any one instrument could provide. From the vantage point of the orbiting laboratory, JEDI measures Earth's surface vegetation, producing 3D views of forest height and structure and the surface topography beneath. Forests and other plant life respond to a variety of environmental stresses, and the EcoStress instrument allows researchers to study plant temperature and provides insights into how life on Earth responds to changes in water availability. OCO3 measures atmospheric CO2 with high accuracy, helping researchers better understand CO2 increases and decreases and the impacts of those changes. And through the use of two cutting-edge spectral imagers on the station, HISWI and DESIS, researchers have access to highly detailed information on materials across Earth's surface, from identifying minerals and rock types to distinguishing between plant species. There's another and often overlooked observational instrument on board the space station: crew members equipped with digital cameras. Over 3 million images have been collected by astronauts from the station, and those images can be put to a variety of uses. William Stefanov is branch chief for the Exploration Science Office, a part of the Exploration Integration and Science Directorate at Johnson Space Center. He says handheld cameras used by the crew act as a complement to the data gathered by the station's various instruments. And that comes down to the ability of the crew to take pictures that are panoramic and oblique versus a straight-down look. That panoramic view can be quite useful when observing natural disasters as they occur, such as wildfires or volcanic eruptions. Stefanov explains, a camera is an excellent tool for examining the plumes created by wildfires or volcanoes, because it gives you an immediate three-dimensional picture of what the plume looks like, what its structure is, and how far it's extending. The observational instruments aboard the space station provide science capabilities that are more than the sum of their parts. These instruments, along with photography from crew members, serve to keep a multifunctional eye on the condition of our home planet. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more eye-opening information about space exploration, visit science.nasa.gov.
There's an instrument on the outside of the International Space Station that's been sifting through cosmic ray particles since 2011 to help us learn more about the origins of our universe. But the alpha magnetic spectrometer wasn't designed to operate that long, or to be repaired in space so it could continue its mission. But NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center, along with the folks here at the Johnson Space Center, figured out how to do just that. And in today's Tech on Deck episode, they show us how they did it.
Before I started digging in that other bag, here you go. Yeah, no problem.
If you need to fix something in space that wasn't designed to be fixed, it's going to take all the experience you can get. With that in mind, when the International Space Station's Alpha Magnetic Spectrometer, or AMS, needed repairs, NASA's Johnson Space Center and Goddard Space Flight Center used their joint expertise to make it happen. At Goddard, that expertise resides in NASA's Exploration and In-Space Services Division, or NEXUS, which evolved from the office that was responsible for the Hubble Space Telescope servicing missions. Key to these missions was the development of specialized tools. While you've probably heard of Hubble, you may not be as familiar with AMS, so let's start there. Designed for a 3-year mission of sifting through cosmic ray particles, AMS has been looking for signs of dark matter from its position on station since 2011. Hundreds of researchers have used the data collected to investigate the source of the mysterious substance to help us better understand the origins of the universe. To continue this important data collection, AMS needed an upgrade due to general wear and tear from the harsh environment of space, specifically a new cooling system. A repair could extend its life beyond what was originally planned. Sounds easy enough, right? In fact, due to the instrument's complexity and the fact that it was not designed to be repaired, even gaining access to the system to replace it was difficult. AMS's design did not incorporate the kinds of interfaces that make spacewalks easier, or have the ability to be serviced with traditional multi-purpose tools. And so, over the course of 4 years, NASA got to work designing and developing some of the most complex spacewalks since the Hubble servicing missions in the 90s and early 2000s to fix AMS.
The AMS tools themselves were unique. They were built specifically for this task, a task that was never intended to be performed on a spacewalk. And so that required a lot of thinking about how we were going to get inside so that we could access the tubes that we needed to cut into and then install the new thermal control system, but also how to put handling aids on it so that we had a place to attach our tethers, to attach our foot restraints, to have handholds, have a place to attach equipment that we needed out there.
NASA developed 20 specialized tools to make the job possible, and on November 15, 2019, astronauts Andrew Morgan and Luca Parmitano got to work. On this first spacewalk, astronauts needed to get access. By design, 5 of the tools could be seen floating off into space, attached to the debris shield that was removed to give the astronauts access to the heart of AMS.
The debris shield handling aid was one of the first tools that Luca installed on the EVA, and this gave us a handhold to install on the debris shield to work from, but also a handle for me to hold on to ultimately when we jettisoned it overboard to the aft side of the ISS, which was a lot of fun to do.
The astronauts continued with 3 more spacewalks over the next 2 months, using all of the specially designed tools. One such tool was the Tube Cutting Guide, which was a direct result of multiple practice sessions at Johnson Space Center facilities like the Neutral Buoyancy Lab. While practicing, astronauts communicated the need for a way to identify and verify the correct tubes to cut, since they all look the same to the astronauts' eyes within the spacesuit.
After we had removed the debris shield and the VSB cover, now we have the tubes exposed, and we actually had to cut into those tubes in order to pull out the correct ones to connect with the new thermal control system, the new pump. In order to do that, we had to be very sure of the tubes that we were cutting. These ingenious tube cutting guides installed over the top of the tubes and made sure that we knew and we were communicating correctly with the ground team to make sure that we were cutting the correct tube at the right time.
In January 2020, Luca Parmitano and Drew Morgan completed the 4th and final spacewalk to repair AMS. Because of their work and the ingenuity of tool designers and engineers, the instrument is now back in commission and able to continue to collect data about the origins of our universe for years to come.
People from Goddard and JC spend a lot of time developing these tools with their knowledge and the support of astronauts like Chris Cassidy. And we are very thankful that we were privileged to use those tools and to put them to very successful use. Thank you very much.
If you want another look at any of those stories, go over to YouTube and Facebook at those addresses right there. You'll find them all there, along with lots of other great features on a whole variety of NASA topics. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's a weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan learns about the system that generates oxygen for International Space Station crew members to breathe, and how it is helping to build the technology that will perform that same vital function for future crews on the Moon and Mars. Go to nasa.gov/podcasts for this week's episode, all the previous episodes too, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud. You can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter.